Now that we've found a way to clean up all those nasty leaks, we run into an even larger problem called memory churn.
Remember that each heap space has a finite size that limits the number of objects that it can accommodate. And as the size of the heap gets too big, a GC event is kicked off to eliminate unneeded objects to free up memory.
Now, memory churn is a term used to describe the process of allocating lots of objects in a very short amount of time. For example, if you're allocating a load of temporary objects in the middle of a for loop, or you're allocating a bunch of objects in your onDraw function.
This is effectively the same problem as an inner loop. Anytime the screen needs to be redrawn or an animation is occurring, you'll end up with calls to these functions every frame, which can quickly add up, adding pressure to your heaps.
In both cases, we've created a scenario where a high volume of objects can be created in a very short period of time. And depending on how many of these objects are created or their size per object, you can end up quickly consuming all the available memory in the young generation, forcing a GC to kick off. And as more of these are kicked off, the more of your precious frame time is going to be eaten up by them. As such, it makes sense that for a high performance application, you would want to identify and move allocations out of inner loops or any code that's going to be executed repeatedly. To make finding these allocations easier, Android Studio has a handy tool built just for this problem.